Hello friends, this video on ray optics part 38 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 37 before going ahead with part 38. So how do we determine the diffractive index of the material of the prism? As we know that prisms are made up of different materials depending upon its applications. Sometimes it is made up of glass, sometimes plastic, sometimes fluoride, and so on. So here is an approach to determine the refractive index of the material of the prism. Now we know that refractive index of any medium 2 with respect to 1 is equal to refractive index of 2 divided by refractive index of 1. Now from Snell's law we know that this is equal to sin I by sin R. Now in case of a prism also, if this is my prism, the refractive index inside is N2 and the refractive index outside is N1, right? So we basically want to evaluate the value of N21, that is refractive index of 2 with respect to 1. Now what is this I? Now just in the previous slides we calculated that angle of incidence is equal to angle of prism plus angle of minimum deviation divided by 2. So this divided by sin R. So we also saw that the angle of refraction R was equal to A by 2. So we can say that the refractive index of the material of the prism is given by mu is equal to sin A plus delta M by 2 divided by sin A by 2. Now there would be a special case for thin prisms. If the prism is thin enough, in that case, delta M would be very small. Now, if delta M is very small, in that case, sin, for example, for very small theta, sin theta is approximately equal to theta, right? So, in that case, sin of A plus delta M by 2 will be equal to A plus delta M divided by 2. This divided by A by 2. If we assume that both A, that is angle of the prism, and delta M is very small, because if the prism is very thin, this angle will also be very small. Let us suppose if it is a thin prism, so this angle will also be very small. So this becomes equal to A plus delta M divided by A. Or we can say that mu A is equal to A plus delta M, or delta M is equal to mu minus 1 into A. So for thin prisms, the angle of minimum deviation can be related to the refractive index and the angle of the prism in this way. So for thin prisms, we see that delta M is inversely proportional. Delta M is directly proportional to the angle of prism for thin prisms. That means as the angle of prism increases, delta M increases. As the angle of prism decreases, delta M also decreases. Therefore, thin prisms do not deviate light much because angle of prism is very small for thin prisms. Therefore, the angle of deviation is also very small. So, they do not deviate light much. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.